Welcome students. Today we will discuss interference of light on the basis of Young's double slit experiment. So what is interference of light? When the light waves of same frequency and having zero or a constant phase difference traveling in the same direction superpose each other, the intensity in the region of superposition gets redistributed, becoming maximum at some points and minimum at the other. This phenomenon is called the interference of light. Now what does this mean? When the light waves of same frequency means the light waves coming after a equal intervals, having zero or a constant phase difference means there is no delay between the light waves traveling in the same direction superpose each other. Superpose each other means when they are on top of each other. That means the waves are added. The intensity in the region of the superposition gets redistributed. Means wherever there is superposition of lights, the intensity, that means the brightness and the darkness, is different from your previous case, becoming maximum at some points and minimum at others. Means they become darker at some points and brighter at some points, and this phenomenon is called interference of light. We will discuss your Young's double slit experiment. Now, in the year Thomas Young was the first person to demonstrate this experimentally, the interference of light. Now in this experiment what happened? You had a source. This source is of a monochromatic light which can be a sodium vapor lamp. Now you have two narrow slits, slit S1 and S2 parallel to each other. Now an observation screen is placed at a distance of somewhere around 2 meters from the two slits, and on the screen alternate bright dark bands appear. Now this phenomenon is known as your interference, and this bright and dark fringe are known as your interference fringes. Now what happens in this experiment? Now as your source, as it is a monochromatic source which gives out monochromatic light. Now the light from the source S falls on the slit S1 and S2 simultaneously. Therefore, your source S1 and S2 will act as a secondary source for your light waves. Fine. Now, in your figure, the solid curve represents your crest and the represents your trough. Crest means the upper part of the wave and trough means your lower part of the wave. Fine. Now, at the points O, P2 and P dash, the crest of one wave falls on the crest of the other. Therefore, the two waves superimpose to form a new wave which has a higher intensity. Similarly here, the trough of one wave falls on the trough of the other, so the new wave will have a higher intensity at this point. Clear? So such kind of interference will be known as your constructive interference. Now, at the points P1 and P1 dash, what happens? Your crest of one wave falls on the trough of the other wave. Now when this happens, the two waves superimpose or they cancel each other to form a resultant wave, which will be a simple straight line. That means it will be dark, a dark fringe. Such kind of interference will be known as your destructive interference. Fine. So on the observation screen, we will obtain a alternate of a bright, dark, bright, dark fringes. Now, derive the conditions for your intensity of light. Fine. Now let us consider the wave coming out from the slit S1 be Y1. Y1 is the displacement equals to A1 sine omega t, and the wave coming out from slit S2 be Y2 equals to A2 sine omega t plus phi. Y1 and Y2 are your displacement, A1 and A2 are your amplitudes, omega is your angular frequency, and t is your time. Now since the two waves interfere with each other, that means they get added up. Therefore, by the principle of superposition, y equals to y1 plus y2. That means you have to add this one and this one. Now on further simplification, that means by expanding this term and by taking few terms common, I can write y equals to a1 a2 cos phi sine omega t plus a2 sine phi cos omega t. Fine. Now put this a1 a2 cos phi term as a cos theta, a2 sine phi term as a sine theta. After substituting these values, you have a cos theta sine omega t, a sine theta cos omega t. Take this amplitude common, and this represents your sine a plus b formula. Therefore, using sine a plus b formula, y equals to a sine omega t plus theta. Now this represents your resultant wave, which is harmonic in nature. Harmonic means it repeats after every equal intervals of time. Fine. Now y represents your displacement, a represents your amplitude, omega represents your angular frequency, t represents your time, and theta represents your phase difference. Fine. Now on the basis of this equation, the amplitude, or I can write the amplitude expression as a square equals to a1 square amplitude of the first wave square, a2 square amplitude of the second wave, plus twice of a1 a2 times cos phi. Phi is the phase difference. Fine. Now we know intensity of a wave is directly proportional to the amplitude. Therefore, I can write I equals to I1 plus I2 plus twice of root over I1 I2 cos phi. Fine. So this is your intensity expression. Now in this intensity expression, this term twice of root over I1 I2 cos phi is known as your interference term. Fine. Now in our next class, we will derive the conditions for your constructive interference and destructive interference. Fine. So for homework, two plane monochromatic waves propagating in the same direction with the amplitude a and 2a and differ in the phase by pi by 3 superpose. Calculate the amplitude of the resultant wave. Okay. So class, thank you, and if you have any confusion, please ask me. I will re-explain it to you again. So thank you.